Applications of differentiation, finding turning points. Find the turning points of the curve y is equal to x plus 1 over x. What we need to understand here is at the turning points the slope is 0. Let's take a look at the graph of this curve using GeoGebra. Here we have the curve and a tangent to the curve, and you can see the slope is shown. We can see as we approach the turning point, the local maximum or minimum, the slope of this curve becomes 0. So in other words, dy dx, the derivative of the curve, is 0. You see this is true at both turning points. If you're paying attention here too, you might see the answer happens when x is -1 and x is +1. But the important thing for any curve is that at the turning points, the slope is 0. So we want the slope function dy dx to be equal to 0 to be able to find the turning points. So to be able to differentiate this curve, it's easier to write it in index form first. We differentiate it by multiplying by the power, reducing the power by 1. Now at the turning points, this slope function is going to equal 0. So we're going to write 1 minus x to the -2 is equal to 0. If we multiply everything here by x squared, it creates a simpler equation here. So we get x squared minus 1 is equal to 0. This is the difference of two squares if you wish. But we can see the solutions to this will be x is equal to 1 or x is equal to -1. So there's two options to this, given that x squared equals 1. So we have the x value, and that's what we saw in the diagram earlier on as well. So to find the corresponding y value, we'll sub these values into the original curve. So when x equals 1, we get an output of 2. So we have the point 1, 2. And if we sub in x equals -1 into the curve, we get the second point, giving an output of -2. So that gives the other point is -1, -2. So that's how we find turning points on a curve.